Today we're going to simplify square roots with variables. So your target is I can simplify square roots that include variables. First, let's look at a perfect square variable. Perfect square variables are variables that have an even power. Example, x squared, x to the fourth, x to the sixth, and so on. When you take the square root of variables, you have to remember that for every two of the same factor inside of the radical sign, one factor comes out. So if you have x squared, or the square root of x squared, then that's the square root of x times x. So since you have two x's inside, then one will come out. That's why all even powers are perfect squared, because they will all have sets of two underneath the radical, and you'll be able to pull one out. So let's look at some more examples. Alright, so I have x to the third, which if you expand it is the square root of x times x times x. Well, for every two inside, one can come out, but then there's one left on the inside. So the square root of x to the third becomes x square root of x. Now I told you at the beginning that x to the fourth was a perfect squared variable, so when you take the square root of x to the fourth, that expands to the square root of x times x times x times x. So 2x's in gives you 1 out. 2x's in gives you 1 out. Nothing's left under the radical, so x times x is x squared. So you can see the square root of x to the fourth is x squared. Let's look at the square root of x to the fifth. That's the square root of x times x times x times x times x. So 2 in, 1 out. 2 under, 1 out. This one doesn't have a partner, so it has to stay underneath the radical. So I have x times x on the outside, which becomes x squared, and I'm left with 1x on the inside. So you can kind of see the pattern. The perfect square one, like x to the fourth and x squared, doesn't have anything left over. And you can see the power of 4 changes to the power of 2. X to the third, you have an x to the first on the power on the outside and an x left on the inside. For x to the fifth, you have an x squared on the outside and an x on the inside. So if you divide these powers by 2, that whole number that it divides by will be the power of the variable on the outside. So 3 divided by 2 is 1.5. So you have an x to the first on the outside and you have a leftover x on the inside. 4 divided by 2 is 2, so you just have an x squared and you have nothing left on the inside. 5 divided by 2 is 2.5. So that x squared, the 2, becomes the power of the outside, and you're always going to have 1 left over on the inside when you have an odd power. So there's a shortcut way, instead of writing them all out and finding the pairs, to simplify variables. And that shortcut is you can divide the power of the variable by 2. The whole number becomes the power on the outside. If it does not divide evenly, then the leftover variable stays on the inside. So let's look at some examples. I will do some where I expand them out, and I will also do some where I use the shortcut. Alright, let's look at number 1. Number 1 says I have the square root of 64b squared. Right. I recognize that 64 is a perfect square, but in case you don't and you go to do the prime factorization, you have 64 is 8 times 8. Now I'm going to stop there with my prime factorization because I remember the rule. Every two of the same factor under brings one out. So I'm going to leave 64 in terms of 8 times 8. And b squared equals b times b. So I'm going to change this to be the square root of 8 times 8 times b times b. So for every two factors inside, I can bring one out. So I have 2 8s and I have 2 b's. So that means I can bring an 8 and a b out, and nothing's left underneath the square root. So this simplified into 8b. So 64b squared is a perfect squared expression. Alright, let's look at number 2. 128 I don't recognize as a perfect square, so I'm going to do my prime factorization. And I divide it by 2 because it's an even number. And so 128 divided by 2 is 64. Well, we just used 64 over there, and I know it's a perfect square number. It's 8 times 8. I'm not going to keep breaking this down because I know if I have 2 under, I can bring one out. So I'm going to leave it as 8 times 8. So this is going to be the square root of 2 times 8 times 8, and I got the v squared, which is v times v. So for every 2 underneath, I can bring 1 out. So I can bring out an 8. I can bring out a v, but my 2 doesn't have a partner, so that has to stay under the square root sign. So I have 8v square roots of 2. All right, number 3 says that I have the square root of 45, x to the third, y squared. So 45, if I break it down, that's 9 times 5. And I recognize 9 is a perfect square, is 3 times 3. So I'm going to change this to the square root of 3 times 3 times 5 for 45. X to the third is x times x times x. And y squared is y times y. So for every 2 under, I can bring 1 out. So I can bring out a 3, I can bring out an x, and I can bring out a y. So my things that are left without partners, a 5 and an x, have to stay underneath the radical sign. So this simplifies down into 3xy times the square root of 5x. All right, let's look at number 4. This time I'm not going to write the variables out. I'm going to use the shortcut. I still have to deal with the 72, so I break it down. I know 72 is divisible by 9, so I do 9 times 8. And 9 breaks up into 3 times 3. And 8 breaks up into 4 times 2. And then 4 will break up into 2 times 2. So 72 will end up looking like 2 times 2 times 2, all the 2's, and 3 times 3. And then I got m to the third n. So for the numbers, every 2 inside, 1 comes out. So I'm going to have a 2 on the outside. I'm going to have a 3 on the outside. Now I got the m to the third. So I'm going to take that 3 and I'm going to divide it by 2. And if I take 3 divided by 2, I get 1.5. So I know I can pull out 1x. It's going to have the power of 1. But I'm going to have, because I have that 0.5 left over, I'm going to have an x, sorry, not an x, an m. So I can pull an m out because that 2 goes into 3 one time. But that leftover m has to stay underneath. So now I got the square root. 2 will be underneath, 1m from that odd power, and n is an odd power. There's nothing to pair it with, so n is underneath. Now I have to simplify the outside. I can do 2 times 3. 2 times 3 is 6, m on the outside, times times the square root of 2mn on the inside. All right. I have 4 more examples for us to do together. These ones have that coefficient out in front. And remember, with the coefficient out in front, we're just going to leave it there and operate it with it in the final step in our simplifying. So here I'm going to look underneath 64. Hopefully by now you're recognizing that's a perfect square of 8. M to the fourth, since it's an even powers of perfect square, I'll divide the power by 2. And n to the third is not a perfect square, so I'll have to take that 3 divided by 2, which gives me 1.5. So this becomes the power on the outside. And this means I have 1 left on the inside. So my -4 from the coefficient at the beginning. The square root of 64 is 8, so 8 comes out. The square root of m to the fourth, which will be 4 divided by 2, will give me m squared. And n to the third, the square root of n to the third, I'll take 3 divided by 2, so I'll have 1n on the outside, and I'll be left with only 1n on the inside, because 64 and m to the fourth are perfect squared variables. They come out 8m squared. N to the third is not a perfect square, but we can simplify it. I can divide it by 2 and it goes in 1 time, so I get 1n out, and I'm left with that 0.5 remainder, which means I'm left with 1n on the inside. So now I simplify my -4 times 8, and I get -32 m squared n times the square root of n. All right, let's look at example number 6. It says 2 times the square root of 16, x to the 4th, y to the 4th. I look at everything underneath the square root, and I say, oh, 16 is a perfect square number because it's 4 times 4. X to the 4th is a perfect square number because it's even power. Y to the 4th is a perfect square variable. Sorry, x is a variable also. Perfect square variable because it has an even power. So everything under the square root is a perfect square. So I'm going to take the square root of each thing. The 2 comes from the coefficient on the outside. The square root of 16 is 4. The square root of x to the 4th, I just take 4 divided by 2. Right here, the square root means that I'm going to divide by 2. So 4 divided by 2 is just 2, so an x squared comes out. And then y to the 4th will also be 4 divided by 2, which is 2, so a y squared comes out. Now I have to multiply the 2 times the 4, which is 8, x squared, y squared. All right, number 7. Number 7 says I have negative 8 square root of 45, m to the 3rd, n to the 4th. So I keep my negative 8 on the outside. And I see 45 is not a perfect square. So I'm going to do my prime factorization. 45, 9 times 5. 9 breaks down into 3 times 3. So that's going to be the square root of 3 times 3 times 5. In case you're not good with the division, I'll show you another one where you can write out the variables. So m to the 3rd is m times m times m. And n to the 4th is n times n times n times n, all under the square root. So here we're looking for pairs. There's 2 3s, there's 2 m's, there's 2 n's, and there's another set of n's. So I know I can pull out a 3, an m, an n, and another n. So I have the negative 8 from the coefficient at the beginning of the problem. 3, m, n times n. Square root, I'm left with a 5 underneath and an m underneath that don't have partners. So now I'm going to simplify negative 8 times 3 and n times n. So I got negative 24 m n squared, square root of 5m as my final answer. So these two showed you using the division shortcut. And in case you don't know in case the division shortcut confuses you, you can still always list them out and look for pairs. All right, so number 8, the last one. We have 18 underneath there, and 18's prime factorization is 9 times 2, and 9 breaks down into 3 times 3. So I got a negative 2 on the outside. On the inside, I got 2 times 3 times 3. And then I got an x to the 4th, y squared, both perfect squared variables because they have even powers. So I got the negative 2 from the problem. I got a pair of 3's on the inside, so 3 can come out. Perfect squared variables, so the square root of x to the 4th, I divide the power by 2, will give me x squared. And the square root of y squared, 2 divided by 2 is 1, so I'll just bring out 1y. So I took care of the x to the 4th and the y squared by dividing the powers by 2, and then I'm just left with a 2 on the inside. Now all I have to do is simplify negative 2 times 3, which is negative 6, x squared y, square root of 2, as my final answer. Alright, we'll practice some more of these tomorrow so that we can reach our target of I can simplify a square root that includes variables.